Hello, ladies and gentlemen. Today we're going to talk about finding the surface area and volume of pyramids. Okay, so you're definitely going to want your notes, get some really good notes taken, some really good formulas written down, and you're going to want a calculator because we'll type everything into our calculator and definitely something to write with. So let's get started. So before we can start talking the math of, let's just get a little bit of common understanding of what pyramids are. So pyramids are going to relate really similarly to our prisms, okay, except for pyramids are only going to have one base. So if you wanted to write that down, that's the difference here. So that's going to change up our formula just a little bit because now we only have one base. So again, just like a prism, they can have any type of shape for a base, a square, a triangle, a hexagon, and so on. But now we have lateral sides, and every single lateral side we ever talk about, they're going to be triangles. If you look in this picture here, pyramids always have a point. So they always have sides that meet at a point, but every side of this pyramid, doesn't matter what the base is, every side of this pyramid is going to be a triangular shape. So that's going to help us when we're finding surface area because then we can just find the surface area of that triangle. The most common pyramid you're ever going to see is a square base, just like the one you kind of see here. But we're going to talk about all bases just so that we're familiar with them. So now when we talk about pyramids, there's two different heights that we talk about. So the height that you see here in red, this height is the height that we're used to talking about. That goes from the tip to the center of our base. So the height of our pyramid is what creates a 90-degree angle. Now again, just like we talked about over here that the lateral sides are all going to be triangles, well in order to find the area of a triangle, base times height divided by 2, you still need another height. So we're not going to use the height that goes in the middle of our pyramid necessarily because that's not actually on the side we're talking about. So when you look here in blue, this slant height that we're talking about, the slant height is the height that is on the side triangle, so on that lateral side that we're talking about. It doesn't go straight down to the base, but it goes straight down to one of the sides of our bases, okay? So it's still creating that 90-degree angle you're seeing here, but again, it's a slanted height because it's talking about the height that's on the surface of one of our lateral sides, okay? So that's one of our new vocab words that you're going to want to focus on. The slant height again goes from the tip of our pyramid to the center of one of our sides of our pyramids, okay? So as we kind of work with that, that's maybe a little bit confusing, but we're going to need that as we jump forward and talk about this formula. All right, so when we have our pyramids, we have two new formulas, okay? So we have the surface area and volume, just like we have with our other two shapes we've talked about. Surface area, volume. Okay, so we're going to want to talk about both, but before we can use these formulas, we're going to have to break down what they mean. So just like in the other ones, let's give a definition to every different letter we see. So big B, just like in our prisms, is going to stand for the area of the base. And unlike our prisms, there's only one B, so we're only going to do a 1B. With our prisms, there would have been a 2 out front. But now since we're talking about pyramids, instead of having two bases, we only have one, so we only need to calculate one area of the base. Okay, then we have 1/2 P, and we know what P stands for. P again is the perimeter of the base. Okay, but now we have this L, and again this L is a little different because the L stands for that slant height. Okay, so make sure we get a really good definition here. The slant height goes from the tip of the pyramid to the center of one side of the base. Okay, so then as we jump, those are all the letters we need for surface area. And again, the slant height is the new thing for our pyramids. As we jump into volume then, volume equals 1/3 base times height. Now again, for our prisms, the prism, the volume we had there was just base times height. Now all we're technically doing when we're finding the volume of a pyramid is taking the same kind of formula, but dividing it by 3. So again, another way you could write this is big B times H all over 3. You can write it either which way. This is probably how I'll refer to it just because it's a little bit easier to type it in the calculator that way. So the last variable that we need to write down a definition for is the H. So again, H is just going to stand for that regular height. And the definition of that regular height goes from the tip to the center of the whole base. So that's going to go kind of straight down. That creates that 90 degrees with the whole base. Okay, so again, the two different heights we're dealing with here, making sure you have a good understanding of what both mean, because as we jump forward, we're going to use both to help us find the surface area and the volume. So let's start with our first example here. So our first example, again, we have a pyramid, and we know it's a pyramid because it meets at a point and it only has one base. Okay, so if we look here, now it doesn't necessarily tell us, but we can assume, since it's only giving us this 8 over here, we can assume that this is a square base. Okay, so again, let's write down both of our formulas. We have the surface area formula, which is B plus 1/2 P and then the L. And then we have volume, which is 1/3 B times H, or like I said, I'm going to use it as B times H over 3. So we're going to focus more on that one. I'm going to divide this kind of in two, so that way we can work with one at a time. So let's look at surface area, and let's figure out, let's first off find what all of the letters are. So again, we have big B. We have to determine what big B is. So again, determine what the shape of our base is. The base here, again, like we said, is a square. So now I need to find the area of a square. Okay, if I'm talking the area of a square, we know that should be sides squared, and one of our sides is 8. So I'm going to take 8 squared to get that big B. So when I go up here and I calculate 8 squared, you get back the number 64. Okay, the next thing then we want to talk about is P, so the perimeter. And if I were to calculate the perimeter, again, that's all the way around my shape. So if all of the sides are the same, basically what I'm going to do is take 8 times 4, and 8 times 4 would be 32. Last letter we need to find then to help me find the surface area is L. And again, L stands for that slant height. So the slant height goes from the tip to the center of one of our sides. Now you might be thinking, well, that's not given to me in this example. That's unknown in this example. So we have to do a little bit of work to find it. Now, without me explaining why, I'm going to draw in something here. If I were just to connect the center here to the center there, notice what I just created. I'm going to pull out what I just created. I created a triangle that is a right triangle that I'm trying to find the hypotenuse of. Well, do I know the other two sides of this triangle? If you notice, the height, or this left side, this one's given to me as 12. If I could figure this out, then I could use the Pythagorean theorem to help me find the hypotenuse. But notice here, we don't know that. If I fully extended that across here, we'd be talking about the whole length of a side of this square. So notice that this whole side would be 8. Now again, it's going to the center. This height here is going to the center of this, so this should be cut in half, meaning that this bottom one, since the whole side length is 8, this bottom part of my triangle is actually 4. So here, now I have a triangle that I've created, and again, this is some side work so I can help figure out that slant height. But this side work here, now I have a triangle with two sides. To find the hypotenuse, I have to use the Pythagorean theorem. So I'm going to take 12 squared plus 4 squared equals x squared. So I get 144 plus 16 equals x squared. Then I get 160 equaling x squared. When I take the square root of both sides in my calculator, I get back a decimal of x equaling 12.65. So what that means over here then is that L that I found is 12.65. And again, I had to do some side work to help me figure that out because everything else kind of we could figure out, again, you have to just figure out all of your variables first, and once you figure out all your variables, you can just plug them straight into this formula. So if I were to plug it straight into the formula to find the surface area, big B we found was 64 plus 1/2. P we found to be 32. And then L we found to be 12.65. And again, just like everything else, let's always use 2 decimal places. So once you type that out, again, this just becomes a process of typing it into your calculator. So 64 plus, now 1/2, I'm not going to type in that fraction, I'm going to just type in 0.5, and I'm going to use parentheses when I type that in. So I'm going to type in 64 plus 0.5, parentheses, left parenthesis 32, right parenthesis, left parenthesis 12.65, right parentheses, and when I type that in and I hit enter, I actually get back just the number 266.4. And again, I have to give it a good label, but there's no label here, so when I'm talking about surface area, remember that's just units squared. Okay, so surface area is always units squared, volume is units cubed. Okay, so if you have any questions as I worked through that, I might have gone through it a little fast. Jot down those questions and we can get them answered when we talk, okay? So then let's go over here and let's talk volume. And if I talk volume, I'll change my color so it's not as confusing. We're going to use this formula here. Big B we already found, so big B is going to be 64. Now H, what does that H stand for again? Again, H stands for the height of our pyramid. So the height goes from the tip of our pyramid to the center of the base. So it drops straight down and it's kind of on the inside of that pyramid. Okay, so then when it drops straight down, we already actually know that distance to be 12. So I'm just going to steal the distance and put it all over 3. So again, in my calculator, using parentheses exactly as I wrote it out here, I'm just going to type in left parenthesis 64, right parenthesis, left parenthesis 12, right parentheses, and I'm actually going to hit equals after that, and then I'm going to hit divide by 3. And when I do that all in my calculator, again, it's a lot of calculator work, I get back the number 256, and again, a good label would be units cubed because we're talking about volume. So if you have any questions as I worked through those problems or where I got each number, make sure you jot those down so we can get those answered. All right, example 2 here. Example 2, it looks like our pyramid has a different base than what we had before. This time we have a regular hexagon. So I'm going to try and jot a picture down here of our regular hexagon so we can do just some side work with what we've already known. So again, this goes back to week 2 of our online learning when we had to find the area of a regular hexagon. So hopefully you remember that we need to jot in this triangle and then find the area of this triangle. So we know the whole side is 6, so the bottom here is going to be 3. And let me backtrack a little bit here. Again, I'm trying to find the area because the area of the base because again the surface area formula is big B, which stands for area of the base, plus 1/2 P times L. Okay, and again we're going to do 2 different steps here. We'll also do volume over here, which is big B times H divided by 3. So again I jumped the gun a little bit, and over here we want to do the area of the base to find big B. So that's what I'm doing here with my hexagon, my regular hexagon. So I know that this bottom length is going to be 3 because the whole length is 6 and I cut that in half. But now I need to find the height of my triangle in order to figure out the area of my triangle to help me find the area of the big base. And again, this all goes back to area of regular polygons. So if you need help with that, make sure that you jump back to week 2 of our online learning. Okay, so if I could find this angle here, I would be able to use trig to help me find the height of my triangle. So this, in order to find this angle, remember the whole angle, the whole amount of degrees in a circle is 360. In a hexagon, I'm going to have 12 total little triangles. So I'm going to take 360 divided by 12. And that actually gives me an angle of 30 degrees. So now I'm going to use trig, which I have the opposite side and I have the adjacent side, so that's going to be tangent. And again, I'm working through this a little fast just so the video doesn't run too long. So tangent of 30 equals 3 over x. So in your calculator, you could type in x equals 3 divided by tan 30, and you would get back a number that is 5.19, and then it rounds up, so it's going to be 5.2. So the height of this triangle is 5.2. So now to find the area of the base, I have to take the 5.2 times the 3 divided by 2, because that's the area of this whole triangle. Once I get that, I'm going to take that number in my calculator, I'm going to multiply it by 12, because there's going to be 12 total triangles inside there. And the number you get back when you do all of that is actually 93.6. So we just found the big B to be 93.6. All that work just to find the big B. Okay, so then we got to find P. So perimeter, again, that's the perimeter of the base. So when I go all the way around the base here, all of these sides are 6. So I can take 6 times 6, which the perimeter then would be 36. The last variable we have to find for surface area then is the lateral height. So again, we have to think about this triangle. So I want to make a triangle in here. We know that from the tip down, this part here is 8. That's what it says over here. We also found the distance from the center to the edge of the hexagon is 5.2. We did that work right here. That's what x was, because that's the center to this, the center of our hexagon to the center of one of the sides. So again, that's 5.2. So if I were to kind of jot in, and this is maybe a little hard to see, so if you do have questions, jot them down. I need to find, I'm going to pull out that triangle that we just created again. We found that this is 5.2, this one is 8, and I need to find that slant height. So again, I'm going to use the Pythagorean theorem. So I take 5.2 squared plus 8 squared equals x squared. So when I type that into my calculator, I'm just going to type in 5.2 squared plus 8 squared. And that number I get back is 91.04, and that equals x squared. So again, take the square root of both sides. So I'm going to get back an x value of, the square root of that is 9.54. So x is 9.54. So when I go over here to my lateral height, 9.54 is what that L will be. So again, then we just plug it into our formula. I'm going to change my color so you know what I'm doing here. And I'm actually going to go to the bottom over here because I know I'm going to have this room. So surface area is going to be big B, we found to be 93.6 plus 1/2 perimeter, which is 36, times the lateral height, which is 9.54. So again, we're going to type that all into our calculator, type in 93.6 plus, for the 1/2, I'm going to use 0.5. So plus 0.5 times 36 times 9.54, and again, using parentheses and all of those. Okay, so we use parentheses, and when you type that all into your calculator, you get back a total value of 265.32, and again with a good label, centimeters squared. Okay, so again, this is our surface area, and using good labels. I know I'm talking kind of fast, but the video is getting a little long, so I got to talk a little faster. Okay, so the last thing then is our volume, and it looks like we have everything for our volume. Big B we already found to be 93.6. The height from the tip of our pyramid to the center of our base is the 8 centimeters that was given to us, and it's all divided by 3. Using parentheses, type those in, okay, and you get back, or you should get back, a number that's 249.6 centimeters cubed. And again, I know I kind of talked a little bit fast through both of these as I plugged them in, but if you have any questions at all, make sure you jot those down so we can get those answered when we meet this week, okay? So I want to thank you for taking good notes. If you're still with me, let's do something fun here. If you're still with me, email me the code word purple elephant. Email me the code word purple elephant. Okay, the first 3 people that do this, and email me their address, I might have a little treat. I'll drop you by a little gift on your front step, okay? So if you are willing and you want a fun gift, the first 3 people that email me Purple Elephant and their address, I will drop off a fun little gift on your doorstep, okay? So thanks for watching all the way through, people. I will hope to see you soon. Have a great day.